So in the previous class we have studied about t-test. Whenever your sample size is less than 30, you require t-test to compare the mean of the sample with that of the population, or you wanted to compare the means for two different samples. So we have seen that for the independent case you have two different samples taken from two different populations, right? So you wanted to compare the means of these two samples. So the thing was that these two samples, they were independent of each other. So that means one does not have any effect on the other sample. However, in the pair t-test, these two samples, they are dependent on each other. So once the effect of one sample would be seen on the second sample, and so on. So therefore, in this case, whenever we have dependent samples, we use t-test. In fact, paired t-test, right? So this is the name, and the application of this test is very simple. If you remember the t-test for single mean, this is the same as that, but after doing certain modifications. So in certain situations we are having various measurements where we see the effect of one measurements on the measurements from the experiment made measurements made after the experiment. So in that case we say that the observations, they are paired with each other. So how do you compute that in this case? So if I say we have for the first sample the data points are given by this. So this is the random variable corresponding to first sample, and then we have another data points given by yi. So that would be the random variable corresponding to sample number 2. So in this case we have these two samples, and both of these, they are depending on each other. So what we do, we create another random variable. We create a new random variable and we call it by d. So what is d? D is the difference of these two random variables. So from the data values we create another data which is the difference of these two. Now we apply the test onto this difference. So what we do, we compute the mean for this difference random variable. So we compute mu of d, right? And then in fact we compute x bar of d, that would be the sample mean, and we compute s of d, that would be the standard deviation for this newly created random variable, and then we apply the test. So how do we apply the test? Suppose in this case you said your null hypothesis as mu d is equal to 0. So what does it mean? What is your mu d? It is equal to mu1 minus mu2. That means the difference of the means of the first population and the second population. So according to this, you set the null hypothesis as mu d is equal to 0. So basically what we are saying there is no difference between so mu1 minus mu2 is equal to 0. That means there is no difference between the means of these two samples. So this is what we are formulating as a null hypothesis. In case of alternative hypothesis H1, we say that this mu d is not equal to 0. If this mu d is not equal to 0, so that means we would be saying that mu1 is not equal to mu2. So in this case, this would be your two-tailed test. And if you set your hypothesis like this, H1 such that this mu d is greater than 0, so that means what you are saying, your mu d is mu1 minus mu2, that is greater than 0. And what does that mean? It means mu1 is greater than mu2, right? So this is your which tail test? This is your right tail test. Whenever your mu d is greater than 0, so this is your right tail test. And in the third case, you may also set your alternative hypothesis like this. You may say that your mu d is less than 0. So what does that mean? It means that mu1 minus mu2 is less than 0, and it further means that mu1 is less than mu2. In this case, you say that your test is left tail test. So this is the left tail test, right? So this is the test over here. And in this test, what is the degree of freedom? So degree of freedom is the number of samples minus 1. Here obviously you can only subtract these two quantities whenever the number of samples in x1 and the number of samples in x2, they are both equal to each other. So according to this theory, let's see how we can apply this to solve a problem where two samples are given to be dependent on each other. So here we have this question which says that the following are the average weekly losses of worker hours due to accidents in 10 industrial plants before and after a certain safety program was put into operation. So these are the weekly losses of worker hours before that seminar occurred, and these are the weekly losses of workers after that seminar occurred. So now in this case, obviously these two are linked to each other because the safety program that took place would affect the number of weekly losses that occur before and after. If the program was effective, people would be more careful and they would say that the losses would occur less. And if this program is not worth convincing, then there would be no such difference. So the manager who is controlling all these things, so he wanted to test that whether the safety program is effective at 5% level of significance or not. So that person wanted to check whether there is any effect of this program onto the weekly losses of worker hours or not. So this is what we wanted to test in this particular case. So for the solution of this question, the first thing that comes to our mind is setting of the null and the alternative hypothesis. So here these two hypotheses are obtained from the statement itself. So in this case, we wanted to test whether the program is effective or not. So as an alternative hypothesis, we will check that the safety program is effective. In words, this is the statement. Now in terms of hypothesis, how we can write this thing? Safety program is effective whenever, now here you have to use your common sense. When can you say the safety program is effective? Whenever the weekly losses occurring after this program would be less than those occurring before this program, right? So that means we would say that mu2 in this case would be less than, because these are the losses, and we after the program we want the losses to be less. So we want the mean of second sample to be less than the mean of first sample. So that means we would say mu1 minus mu2 is greater than 0, or what is this thing? This is mu of d. So we will say mu of d is greater than 0 in this case. So this is your alternative hypothesis. Corresponding to this alternative hypothesis, now which tail test you will use here for this hypothesis mu d greater than 0? So for mu d greater than 0, we will use the right tail test here. So according to that, we will use the right tail test, right? So corresponding to this alternative hypothesis, your null hypothesis would always say that there is no difference the program that is making. So we will say that mu1 would be equal to mu2 here. So in this case, we will say mu1 minus mu2 would exactly be equal to 0, or we will say mu d is exactly equal to 0. So this would be our null hypothesis. So according to this null hypothesis, what we are to do? We are to create another variable d. out of the given data. So let me write down the given data once more. It is for x we are writing it before the program, for y we are writing it after the program. So we have 45 here, 36 here. So their difference, let me first write down the data. It would be 73, 60, 46, 44, 124, 119, 33, 35, 57, 51, 83, 77, 34, 29, 26, 24, 17 and 11. So this is the data. Now you are to calculate this d. So how you can do that? You have to calculate the difference among these. So 45 minus 36, that would be 9, 73 minus 60, that would be 13, and then 2, then 5, then we have minus 2, yes, minus 2, and then that is 6, this is also 6, and then we have 5, then we have 2, and then we have 6. So this is the value of d. Now corresponding to this d, one thing that I have not told you here, how to compute t in this case, that is the most important. So here you will compute the t by evaluating the mean of all the mean of the newly created random variable divided by the standard deviation of newly created random variable. Here the population would always be 0, population mean, because in this case we will test ud is equal to 0 or not. This is for the null hypothesis. So according to this, this t would be calculated by calculating d bar minus 0 by standard deviation divided by the square root of the number of elements present in the sample. So this would be your test statistic in this case. So for that we would require to compute the average and the standard deviation of this newly created random variable. So for this data, we firstly have to calculate what is d. So d would be obtained when you add up all the elements di and then you divide by total number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations. So this would come out to be 5.2. You may check this thing, and the standard deviation, that would come out to be 4.08. So when you have calculated these two values, as you already know, so your t statistics, the t calculated, that would be calculated using the formula d bar divided by the standard deviation st divided by square root n. So it would be 5.2 divided by 4.08 divided by square root 10. So this number would be 4.03. So this is your calculated value of t. So after having this value, the next task is to obtain the tabulated value of t. So for that you require two things. One is the level of significance. It is given to be 5%. And another thing that you require is the degrees of freedom. So we have the level of significance as 5%, and another thing we require degrees of freedom, that would be the total number minus 1. So we have 10 minus 1, that is 9 degrees of freedom. So for this we wanted the value of t for 9 degrees of freedom at 5% level of significance. So that means 0. So it would be 1 minus 0.05. So it would be t9 0.95. So let's have a look at the table. What is the value? For 9 degrees of freedom, this represents degree of freedom, right? New degrees of freedom. And we require at 5% level of significance, so it would be t.95. So your value would be 1.83. This would be the value. Yes. So your tabulated value would be 1.83. So let me write down 1.83. So now we have to mark this critical value onto our distribution. So say this is 0 because we have right tail test, so this is the value 1.83. So this is your critical region. Now your calculated value is 4.03. So 4.03 would obviously lie somewhere here. This is the calculated value. So it will lie in the critical region, the region of rejection. So therefore we say that we reject the null hypothesis H naught, which was mu D is equal to 0. If you reject the null hypothesis, therefore we accept the alternative hypothesis, which says that mu 2 is less than mu 1. So therefore your alternative hypothesis, it states that the safety program is effective at 5% level of significance. So from the test we so let me write down the conclusion. So we conclude that the industrial safety program is effective at 5% level of significance. So that means the losses in the worker hours due to accident became less after this program take place in that particular plant, right? So this is all about paired t test.